All right, here we go. We are going to work on this worksheet. Are you ready? So for part A, we have to label combustion, decomposition, double replacement, single replacement, or synthesis. So let's look at one. What do I have here? Well, I have two reactants and one product. So I'm building something, making one thing out of more than one thing. That's synthesis. What do I have here? Well, I have one reactant, one thing I start with, and two products. I end up with two things. So what I did is I took this one big thing and I broke it apart. That is decomposition. What do I have here? Well, first you should see I have all four compounds. How do I know? Each one of these has at least two elements. There's two capital letters. So when I have compound, 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 it is double replacement. What do I have here? Well, I have four things again. So at first glance, you would want to say it's double replacement again. But look, you see right here, that is a single element. See right here, that is a single element. So what happened? Well, zinc came in here and replaced the hydrogen. The hydrogen popped out. So hydrogen is alone because that is one singular element on that side. And zinc is alone. That's one single element on this side. They switched places. Single replacement. What do I have here? All right, well, two things on this side, one thing on this side. These are reactants. These are products. So what is that? If I have two reactants that are come together and form one product, I build one big thing. That is synthesis. Let's look over here. I start with one thing. I end up with two. So I took one thing and I broke it apart. So that is decomposition. What do I have here? Well, this looks familiar. See this? I have a singular element on this side and a singular element on this side. What happened is this F swapped places with that Cl and the Cl came out. So this is single replacement. What is happening here? Well, here's the key. Look at these products, carbon dioxide and water. That should be a red flag. And look at this. It used oxygen to get there. Took a hydrocarbon, added oxygen, and made carbon dioxide and water. That is combustion. What do we have here? Well, this is a complicated looking one. Ready? Compound, 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 compound. When everything is a compound, right, we have double replacement. Because what happened is these swapped places, Ba and Na swapped places. And what do we have for the last one? Well, let's see. We have this compound with oxygen. Okay, single element. Do I have a single element on this side? No, I do not. But what do I have? Carbon dioxide and water. So when I take something and I add oxygen and I get carbon dioxide and water, what do I have? Combustion. There we go. All right, now we are moving on to B. Are you ready? This is first I'm going to decide if the reaction is going to happen. So decide if single replacement will occur. If it will occur, so if it will not occur, just write no. If it does occur, write the chemical formulas for both products on the line. Okay, so in order to do this, I need to use table J. So do you see it on the screen right here? Notice that the most active metals are at the top. The most active nonmetals are at the top. And so here is the rule. So if it is more active it must be in the compound. Why? Because it is stronger. So they cannot be alone. So the more active elements cannot be alone. Okay. So let's look. Cr and Fe. So we got to find them. Find Cr and Fe. Well, if you find them, you see that the way it is Cr is here, and right below it is Fe on this table. So that means Cr must be in the compound because it is more active. Is it in the compound right here? No, it is not. Look, it is alone. So what will happen is they will swap places. Okay, so Fe will come out and be alone, and Cr will take its place and form a compound with SO4. Now, I do have to check to see if this formula is right. Okay, so in that case, I have to look at the periodic table. Okay, and when I open the periodic table, I'm looking for charges. Okay, so let's just make this a little bit, oops. No, I don't want this one. I need the periodic table. Here we go. Okay, but I need to make this a little bigger. And here's chromium. Now, it doesn't say which chromium I have or which iron I had, but I can see that Fe was Fe2 because SO4, if I look it up on table E, has a -2 charge. Okay, so this is a -2. So that had to be a +2, and chromium does have the option to have a +2. So in this case, I'm actually okay, and I can leave it as it is. All right, so CrSO4. All right, so let's look at the next one. So we have Zn and Ag, right? You got to compare two things that are in the same column, okay? So I have to compare them. So we got to find both Zn and Ag in this list. Well, first of all, Ag is almost all the way at the bottom. Okay. And Zn is pretty significantly above it. So what is the rule? The one that is above has to be in the compound. Is it? No, 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 it is not. So that means they're going to swap places. So Ag is going to come out, and that's simple. I don't have to worry about the charge for Ag because it's alone. And then I have to pair zinc with nitrate. But I have to think about charges. So zinc is +2. And if you don't know it, you look it up on the periodic table. Nitrate is -1. If you don't know, you look it up on table E. Okay, so do these charges balance as they are? No. I need to add another nitrate, which is another -1. So now I'd have 2 negatives and 2 positives. That will balance. So that means I need 2 of the NO3. So I have to put it in parentheses and add a 2. All right. Let's look at the next one. Well, remember how I said I had to compare things that were in the same column? Find Cl, find Na, and find F. Which two are in the same column? These two, right? Where are they? All right, so I have Cl, and then right above it, I have F. So what is the rule? The one that is more active must be in the compound. Is it? Yep, sure is. So no, a reaction will not happen here. There's no swapping. All right, let's look at the next one. So you're going to find these elements and determine which two are on the same side, in the same column. It should be Fe and Li. All right, so find where they are. Well, you should see that Li is at the top. So it doesn't really matter where Fe is. I know it's underneath it. So what is the rule? The one that is on top must be in the compound. Is it? It sure is. So no reaction. Let's look at the next one. Remember, you got to find two things that are in the same column. Which two are they? Well, it's F2 and I2. So where are they? Well, first of all, F2 is at the top. So it doesn't even matter which one is there. I2 definitely has to be underneath it. And what is the rule? The one that is on top must be in the compound. Is it? Nope, nope, nope. It's alone. So what has to happen? The F and the I will swap. So I will get I2, that will be alone, plus BAF2. And this one I don't have to worry about the formula because these are just swapping halogens, and all the halogens have a -1 charge. So I would just swap out the symbol for that element. All right, we have another one, last one. Find which ones are in the same column, and I have to compare them. So it's going to be K and CA. So find where they are. Well, K is pretty close to the top. CA is going to be a little bit underneath it on that column. So what does that mean? Remember, the rule is the one that is on top has to be in the compound. Is it? Nope, nope, nope. It is not. So what will happen? K and Ca will switch. Writing the formula for calcium is easy because it's just going to be calcium. And now I'm going to have K and S, but I have to think about charges. So I'll jot this one over here. K has a +1 charge and S has a -2 charge. Do those charges balance right now? No. So I need another K because that will give me +2, which will balance with -2. So I need 2 Ks. So I had a subscript of 2 here. All right, that's how you do that section.